f prime of x less than 0 for x less than 5. F prime of x is greater than 0 for x greater than 5. The second derivative at 2 is 0. The second derivative at 8 is 0. The second derivative is less than 0 for x less than 2, union x greater than 8. The second derivative is greater than 0 for x between 2 and 8. The limit as x approaches infinity of f of x is 3, and at both ends. Okay. Okay, perfect. So I copied all this, and as you know, I like to say this is gibberish. Who cares why I don't understand any of this? But it will become extremely clear in a blink. Okay. So I'm going to start with this. The limit of f of x as x approaches infinity and negative infinity is 3. Which obviously means that y equals 3 is what?
Vertical asymptote.
When we calculate an infinity, y equals 3 cannot be vertical.
Horizontal.
Yes. Perfect. Good. So this is done. Don't cross it out like that. I'm just making a point. They're telling us that f prime of 5 is 0. Negative to the left of 0. Positive to the right of 0. The second derivative at 2 is 0. At 8 is 0. A negative second derivative between to the left of 2 and to the right of 8. Positive between 2 and 8. Okay, so obviously this, with whatever you want to put in here, is what type of point? 2 comma whatever, what point is that? And 8 comma whatever is whatever number there. What do you want? What is 2 comma this and 8 comma this? What are they? Can anyone tell us what they are and why?
Two is our relative relative minimum.
Two comma this point. We don't have any
point of inflection.
Yes.
And then 8 as well.
They are connected to the second derivative. Perfect. Awesome. Good. Now we can discuss this. Whatever number you want to put in there, what type of point will be 5 comma triangle?
Intercept, x intercept.
If you want to put 0 here. But we have to look at the first derivative now.
A local min.
Yes. Local or relative. Very good. Because the first derivative is 0, and it changes sign at that point. So the function from 3 to this point has to decrease, opening down. From this point to this point, the function is still decreasing, but opening up. Now between this point and this point, the function is still opening up, but now it's increasing. And then it's increasing to 3, opening down. Okay, ready? The horizontal asymptote. Good. So at 2, 3, 4, 5, 6, 7, 8. 2, 5, and 8. Oh, no. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So something important happens at 2, 5, and 8. So let's see what we do here. Okay. So it's coming from 3, from approaching the horizontal asymptote, decreasing to this inflection point, and then opening up. Okay. Opening down, decreasing from 3 to this point. It's an inflection point, so it has to change concavity. At 5, it reaches a minimum. Okay. At 5, it reaches the minimum, opening up. At 8, somewhere it changes concavity again. 8 comma something, doesn't matter. And now it's opening down because it changes concavity again, approaching 3. Okay, again, opening down from approaching the horizontal asymptote to the inflection point at 2. It changes concavity and now it's opening up, but it reaches a local minimum, and in this case is also the absolute. It reaches an inflection point again, 8 comma whatever you want, higher, lower, it doesn't matter, but not lower than, oh, I went too far. It has to have the minimum at 5. Okay, so it reaches the minimum at 5, local and absolute in this case. It comes up to the inflection point 8 comma whatever you want, higher or lower, but not lower than this value. And then it changes concavity and approaches 3, approaches the asymptote, closer and closer to 3.